Welcome back to another Code Meets World. Today we're going to move on in the bit manipulation category to the reverse bits problem. I have a feeling I know what this one is going to ask. Yeah, simply put, reverse bits of a given 32-bit unsigned integer. And again, we're told the stuff about some languages like Java. I'm gonna ignore that because I think I'm fine in Python. And this one is super straightforward. We're going to be given a 32-bit integer. For example, this string of bits represents that integer. And we need to reverse all of these underlying bits, which would turn into... Oh, okay, I explained that backwards. So if we're given this, that represents this big integer, and we need to reverse all of these bits, so that would give us that, which translates to this number. So basically, given some number, we have to find the bits for it, reverse them, and then return whatever new number that is. So let's talk about how we might go about solving this. So we've seen a lot of bitwise operations so far in the previous couple of videos, and we can take everything that we've learned, plus just one additional fact, and I think we can use that to solve this problem efficiently in O of n time, where n is the number of bits that we have to iterate over. So let's think about a much smaller example of this problem. Say we're given the binary number 7 is input. What we'd want to get as output is the reverse of this, like that. So it seems pretty simple, and it is in theory, but we have to use 3 different bitwise operations, I think, to make this happen efficiently. So let's just walk through the steps that we need to do to solve this, and then I'll explain the bitwise operation that we need to do at each step to make it work. So we start out with, I will list our input n as the value that we are given. I'll also make another value. I can call this a placeholder. I'm just going to call it solution, SOL. And we're going to set that equal to 0. We need this placeholder value because we're going to insert the bits from n into solution, basically by shifting them to the left so that we're reversing it. And you'll see what I mean in a second with how to do that. So what we need to do, basically, is take each bit in n and take it and push it down as far left as we can into solution. Because if we do that for each value, we'll end up pushing a 1 here, a 1 there, a 1 there, and then a 0, and that would give us our solution. But we need to talk about how we're going to do that with bitwise operations. The first thing we need to do is shift everything in solution to the left to make room for the value that we want to add from n. So the way we can do that is by saying n is n shifted to the left. This is the bitwise shift operator by 1. What this does is it takes everything in solution and shifts it 1 to the left and adds a 0 in on the rightmost side while the leftmost side is cut off. So in this case, shifting 0 to the left by 1 just gives us 0, so nothing really happens. Then what we need to do is we need to grab the rightmost bit from n, which is, in this case, that one right there. The way we can do that, and we've done this before, is by saying n and 1. Because if we take n and we do a bitwise and with 1, it'll tell us what this rightmost bit is. Because 1 and 1 is 1, all the other ones cancel out because of zeros. So this gives us 1. That gives us the rightmost bit in n. And then the final step is to put that bit onto our solution value on the rightmost part of it, so right here. And then we're going to shift that down to the left as we go. This is the new thing that we haven't talked about yet. So if we take solution and do a bitwise OR with, in this case, 1. So I can call this the add value. Add can be the value that we need to add on to solution. So if we take solution and we do a bitwise OR with the add variable, this is the same thing as doing 0, or a bitwise OR with 1. This is going to result in 1. So that means solution now equals 1. Like that. And then finally, we need to continue iterating over the n variable. We need to say n equals n, bit shift to the right 1. We did this in the last video. So that chops this 1 off. So on the next iteration, we'll be looking at the next value. If this doesn't make sense yet, I think it makes a little bit more sense on the next iteration, because then we loop through this algorithm again. And the first thing we do is take n and shift it to the left 1. This is the key part, because now we take this 1 and we shift it to the left. So it ends up here, and we fill in the values to the right with a 0. And then we figure out what's the next value we need to add. In this case, it's this 1 up here. So by doing a bitwise OR with the new value for solution, which is currently this, when we calculate that, the new value we get for solution is 0, 0, 1, 1. So we can fill that in up here. And as you can see, we're starting to build the inverse of our input by just taking 1 bit at a time and pushing it onto the solution variable. I'm not going to run through the rest of it because hopefully that makes sense, but a good exercise if you're still confused is to fill in the rest of this algorithm and go through it on a small example, like with a number with just 4 bits in it. But we're going to take a look at how to do this in code now, because I think we have a pretty good algorithm for how to solve it. We'll start out by saying, I'll call it solution, set that equal to 0, and then we're going to loop for each value in, these are 32-bit ints, so we'll just loop 32 times. The first thing, and we're just going to go through each step that I talked about on the whiteboard. So the first step is that we want to, and actually the order of this doesn't matter, so I'm going to do it in a different way than I just talked about it. The first thing I'm going to do is get the value from n to add. Instead of value, I'll say bit. Get the rightmost bit from n to add. We can do this using the bitwise AND operator. So we can say to add equals n, and then bitwise AND 1. So that gets the rightmost bit off of the n value. What we have to do next is shift the bits in solution to the left to make room for this new bit, and so that we're shifting everything to the left as we build the inverse of our input. So that just means we're going to shift solution bits to the left, and we can do that by saying solution equals solution and then left shift 1. In this case, we can just say, I think, solution shift left equals 1. This is the same thing as saying solution equals solution shift left by 1. After that, we need to add the bit onto the solution value, and we can do that with the bitwise OR operation. So we can say that solution equals solution or the to add variable. And then again, we can say solution or equals, I know this looks funny, or equals to add. So that's the same thing as saying solution equals solution or to add. And then finally, we need to iterate through n. And we do that by just shifting the bits to the right. So we can say n, and again, I'll use the same trick, right shift equals 1. So this is just saying n equals n, but shifting all the bits to the right by 1. At the end, I can just return whatever solution is. So let's talk about this one more time. What we do here, and I'm just following the steps from the whiteboard, is I take the rightmost bit from n, and that's the bit I want to push onto solution. So I move solution to the left, all the bits to the left by 1 to make room on the end for this bit that we just grabbed from n. This statement here adds the bit that I grabbed from n onto the rightmost position in the solution value. And then I need to iterate through n so that on the next pass of the for loop, I'm considering the next bit. So we take off the rightmost bit, and now the next time we're considering the next bit. And at the end, I just return whatever solution is, because that's where we're building the inverse of our number. So with all that said, I'm going to run this, and that does work, which is great. So let's go ahead and submit. Yeah, fantastic. So that's a pretty quick solution. Hopefully that's intuitive as well. There's a few other ways to do this, but I think this one makes the most sense, and it's the most readable. And again, that's just my main focus, making something that's easy to understand. I'll see you in the next video.